Lesson 8.3, representing linear functions. So we're going to combine some things that we have done this year to actually graph lines. A linear function, we've talked about functions, none of the x's repeat. We're going to look at the functions that make a line. And we said the other day that every line is a function except one. Do you remember which one that was? Which kind of line isn't a function?
Like one that has more than
non-linear.
No, we're talking specifically a line because we said that, let me see if I can draw this. This line is a function because it doesn't cross more than one point. This line's a function. We said this line's a function. And this one like this one is the only one that's not a function. All the rest of the lines are functions, so you could graph any of those today. And the way that we're going to do it is you're going to find 4 solutions, which the solutions are ordered pairs. And you're going to plot the ordered pair, and then you're going to graph. So we're going to do function tables that look just like this. I'm going to give you the papers that have the tables already drawn on them. You'll just have to fill them in. I will tell you that on every function table, not every, almost all function tables, I want you to use those values for x. -1, 0, 1, and 2. Almost always going to use -1, 0, 1, and 2. At the bottom of this, I'll show you some that you might change it up a little bit. The function's going to be given as an equation of a line, y equals 4x plus 2. So the first column is your list of x's, -1, 0, 1, 2. The second column is where you put the function in. And in that column, what you're going to do is you're going to evaluate what the value of y is if you plug in x one at a time. You're going to fill in what the y's are, and the last column is going to be probably the most important. It's going to give you the ordered pair that you're going to plot on the graph. So let's start off with x is -1. What you're going to write in the chart is this: y equals 4 times -1 plus 2. And then you're going to think to yourself, or you're going to calculate somewhere, 4 times -1 is -4. -4 plus 2, what is that? Braxton?
-2.
-2 will go in the y column. Once you get the y column filled in, you're ready to put in that ordered pair, and you put -1 from the x and -2 from the y. So on my graph, well, I'm going to wait to see how many numbers I need on there, and I'm also going to give you the page of graphs so you won't have to guess at it or put little marks in. It'll be actual graphs. So let's do the next line. Anybody want to do that one for me? Where x is 0. Tori?
4 times 0.
4 times 0 plus 2, which would equal 2. And what is the ordered pair then?
0, 2.
0, 2. Okay, what about when x is 1? Haley?
56.
Okay, well, what do we write in the middle, the second column?
4 times 1 plus 2.
4 times 1 plus 2, and you said it equals 6, so what's my ordered pair?
1, 6.
1, 6. Okay, and then the last column, the last row, where x is 2, who wants to do that? Ryan?
4 times 2 plus 2.
4 times 2 plus 2, which is 10, so my ordered pair is 2 and 10. Okay, so I'm going to do this on my, I've got to go all the way up to 10, so be really careful here. And the other ones I don't have to worry quite as much. So -1, -2, 0, 2, 1, 6. The problem with putting my little marks in is it's not going to be exactly accurate. And then 2, 10. And put my line in as best I can. Yours will be way more accurate because you will have a graph, and everything will be evenly spaced on yours, and it'll be much better. Make sure when you do your line, a couple of things. I want you to take the line throughout the whole graph and put arrows on the ends, because that's what constitutes a line. I don't want you to do this. Go to the last point and just do that. I want you to make your line. Go through the whole graph as far as you can and put arrows on the ends. All right, questions about that? That's kind of a basic problem, kind of your average problem right there. They're going to give it to you in the form of y equals. You plug it in there, use -1, 0, 1, 2, find your ordered pairs and plot the points. Questions about that? So let's say you're doing that, and let's say this point ended up out here. What do you think you should do about that? Any ideas if one of your points ended up out there?
You curve it.
Huh?
You curve the line.
You don't curve the line. A line can't be curved. What if one of your points ended up right here? What do you think maybe we should do? Anybody know? Do you think that a line would really have a point out there? It shouldn't. So you should check your math, because it's wrong. Okay, so double check. If you have one out here, that can't be. These are all going to be linear functions, meaning they're all going to make a straight line. So if anything comes out of line, it's wrong. All right. Now the next one is not as typical. The equation is this: 3x minus y equals 6. Now that's a problem, because in this second column you need y equals to do this. So over here on the right, I'm going to show you how you're going to make this y equals. So I have 3x minus y equals 6. I need y equals. So what's over there on the left that can't be with my y? The 3x term. So it's a positive 3x. To make it go over to the other side, I'm going to subtract 3x. Make sure you write this down so you know exactly how to do this, and draw my line. So 3x minus 3x is gone. Make sure you bring down the negative in front of that y, the equal sign. Can I combine 6 and negative 3x together? Are they like terms? No. And let me just tell you, for the formatting of lines, you always want your x term to come right after the equal sign. So I'm going to write negative 3x plus 6. Those two can't go together any further. That's it. We would be done right now if there wasn't a negative in front of that y. What number is in front of that y? Negative 1. You can't have a negative 1 in front of the y. You can only have a positive 1. So whatever number is in front of that y, you divide every term by that. So every one of these we're going to divide by negative 1. The only thing that's going to do is change the signs of everything. So y equals negative 3x divided by negative 1 is positive 3x. Positive 6 divided by negative 1, negative 6. So if your equation starts out like this, take your x term to the other side. It won't combine with that plain number. You'll have two terms over there. And if there's a number in front of y other than a positive 1, you got to divide every term by it. But now that you've got it in the right form, you can put that in this second column, which it's already been done. Y equals 3x minus 6. And now we do what we did up above. You plug in negative 1, 0, 1, 2, one at a time. to find out the y's. So my first row, I would write y equals 3 times negative 1 minus 6. What's 3 times negative 1? Negative 3 minus 6.
Negative 18.
Nope, minus.
Oh, okay.
Negative 9. So my first point's negative 1, negative 9. Stephen, what do I do on the second row?
Y equals 3 times 0 minus 6.
Okay, and what would my y be?
Negative 6.
Okay, and what would my ordered pair be?
0, comma, negative 6.
Good. Who wants to do the x value of 1? Somebody that hasn't gotten a ticket yet. What do we do with the x value of 1? Somebody that hasn't gotten a ticket yet. Shane.
Y equals 3 times 1 minus 6.
3 times 1 minus 6. Okay, so Shane, what would my y value be?
You do 3 times 1, which is 3, and then you subtract 6, which is
Negative
negative 3.
3. And what's my ordered pair?
Negative 1, negative 3. No, 1, negative 3.
1, negative 3. Okay, and then what about 2? Who's going to do this one? Somebody that hasn't gotten a ticket yet. Dakota.
Y equals 3 times 2 minus 6.
3 times 2 minus 6, and that would be
0.
0. And my ordered pair would be?
2, comma 0.
Okay. And we're not going to graph this one, but if you had to, you'd plot those points and draw your line. About half of your problems tonight, you have to graph, and about half you don't. Okay, questions about that one? Make sure you put it in the form of y equals. This last table that I've got here, oops, hang on. This last table, the equation, the linear function is y equals 3. That's all there is to it. There's no x. Makes you kind of wonder what it's going to look like. But let's see what would happen. You go ahead and put it in the table. You set it up exactly the same. X is negative 1, 0, 1, 2. So if I start with my first row and I say x is negative 1, I look at this column and it says y equals 3. Well, okay, y equals 3. There's no place to plug the negative 1 in. So when I come over to this column, it tells me what y is. What is y? 3. So I put 3, negative 1, 3. Okay? Now I go to x is 0. Well, I still have to put y equals 3. Strange thing is, y is still 3, and I get 0, 3. And that's going to happen for every one of them. Because there is no x, it's for sure going to have y equals 3. So my ordered pair is always going to have a 3 in it. Now, I don't have a graph here, but I do want to show you off to the side because this is really important. Y is 3, and I've got negative 1, 0, 1, 2. So it's going to be negative 1, 3, 0, 3, 1, 3, 2, 3. What kind of line is that?
Straight.
It is, but what horizontal line. So anytime it's just a number, it's going to be a horizontal line through that number. Okay? So that's what that would look like if you had one like that. Now I said I want you to always use negative 1, 0, 1, 2, but here's when you're not going to. If there is a fraction in front of the x, check this out. If it would be y equals 1/3 x plus 2. If you put in negative 0, 1, 2 for x, you're going to get a mess of fractions. So you're better off to put negative 3, 0, 3, 6 because they're going to cancel that fraction out and you're going to have all integers. Let me show you. So if I had y, oops, I guess I better get rid of that. If I had y equals 1/3, let's try 3 plus 2. Well, remember that's 3 over 1, right? And the 3's cancel. it would be y equals 1 plus 2. If it was 1/4 x, you should use -4, 0, 4, 8. If it was 1/2 x, -2, 0, 2, 4.